Alright, so what we want to do from here is to determine if the data set shows direct variation. And in the last problem, well, we determined that one way you could do that is by creating a graph. And if that graph produces a straight line, if it produces a straight line, then guess what? You have direct variation. And if it doesn't produce a straight line, you don't have direct variation. I don't want to do that in this problem. You can if you want, that's cool, but I'm going to actually look at a couple of other ways. Well, one way to do that is to determine if your constant of proportionality is constant, if it's always the same in your data set. So will y over x always produce the same value? So over here we can say, will 25 over 10 produce the same value as 50 over 20 and 75 over 30 and then 100 over 40. And I'm going to change pens real quick. So when you divide these out, 25 divided by 10, 50 divided by 20, you're always going to find out that k is equal to 2.5. K is equal to 2.5. And 75 divided by 30, k equals 2.5. And then finally, 100 divided by 40, you find out k is equal to 2.5 again. So k is constant here. It's always the same value for this data set. Therefore, this shows direct variation. Another way you could do this is by taking this information and just remanipulating it and looking at it another way. So I'm going to actually take the information in this table and just create a t-chart here. So I have x, I have y. Alright, so I'm going to think about time as my x values and distance for my y values. I didn't state that earlier. So my times my x values are 10, 20, 30, and 40. And my y values are going to be 25, and 50, and 75, and 100. Okay, so the other thing I can do is just scale up here on both sides and determine if that scale is constant. Okay, so you can start with any number you want. I'm going to start with 10, and I'm going to ask myself, how did I get from 10 to 20? I had to multiply by 2. So multiply by 2, and I'm going to do the same thing in the same spot on the other side. From 25 to 50, I had to scale up by 2, so multiply by 2. Okay, and you can choose any of the other numbers from 10 to 30, 10 to 40, but I'm going to actually just say, hey, how did I get from 20 to 30? Well, I had to scale up by 1.5 or 1.5. So 1.5 on this side, multiply by 1.5 here. And to get from 50 to 75, I had to do the same thing. I had to scale up by 1.5. So 1.5 again. So when I scale up, it's constant. In fact, I could go the other way. I could actually choose to scale down. And I'm just going to say, hey, how do I scale down from 40 to 10? I'm going to divide by 4 on this side. And how do I scale down from 100 down to 25? I've got to divide by 4 on this side. So when my x values and y values increase, I'm scaling up by the same values. And when they're decreasing, I'm scaling down by the same values. Therefore, the data set here, which is the same above, it shows direct variation. Cool stuff. I'll see you in another video.